Hi everyone. Welcome to another tutorial video. In this video we are gonna be talking about Snowflake. Snowflake is a technology that has been on the drive for quite some time now. I do get a lot of inquiries on my LinkedIn for Snowflake trainings, like how to get started and how to proceed with Snowflake. How do you learn Snowflake from start and how to proceed with Snowflake certifications? We are going to be uploading Snowflake playlist entirely. This is the first video on Snowflake where we are going to be covering an introduction. So this is going to be an introductory video to Snowflake where we cover the basics, and then as we proceed in this lecture we will be making the entire playlist for Snowflake. So you can follow this playlist along if you want to learn Snowflake from scratch and become an expert in the Snowflake technology. Okay, so with that being said, let's proceed with the video, with the tutorial. So in this tutorial, we are going to be covering these following topics. We'll start with learning what is Snowflake. Then as we proceed, we will have an introduction to data warehouse, like what is a data warehouse. And after covering that, we will cover the topic advantages of Snowflake. So what are the advantages of Snowflake? Why Snowflake is on the rise since some time, why everyone is moving towards Snowflake. So yeah, and then we will be looking into what additions do we have in Snowflake. So suppose if I want to be a Snowflake customer, be a Snowflake user, so how, means what additions can I use, and what are the specific entities that I can leverage working on a single specific addition. So we are going to cover that, and at the end we will have a look at the Snowflake pricing model. So what are the features that Snowflake charges us for, and yeah, so without any further ado, let's just quickly jump into the tutorial. So if you see into the slide that is in front of you, into the screen, we first will have a go through on the definition of Snowflake. So Snowflake is one of the few enterprise ready cloud data warehouses that brings simplicity without sacrificing features. So what do we understand by that? It is a data warehouse. It leverages the power of cloud, and it brings simplicity without sacrificing features. It automatically scales both up and down to get the right balance of performance versus cost. So by that, we are trying to say that whenever we need more compute resources for running our queries, for making data transformations, we can automatically scale our compute resource up when we have the higher requirements, or if my business is running low, so in that case I can automatically scale down. So we'll see how to do that when we are into the hands-on tutorials. For now, let's just focus on the theory part. And with Snowflake, you can store all your data in a single place and size your compute independently. So Snowflake does provide us a single central data repository to store all my data, be it structured, semi-structured. It can handle various data formats, and accordingly to perform data transformations or to do any sort of analysis on the data stored, we can also size our compute resources independently. So the storage is decoupled from my compute resources. So now we know that Snowflake is an enterprise ready cloud data warehouse. Like, what is a cloud data warehouse? What is a data warehouse? So let's see what is a data warehouse. So a data warehouse, or enterprise data warehouse, short formed as EDW, is a system that aggregates data from different sources into a single central consistent data store to support various data functionalities like data analysis, data mining, AI, or machine learning. So by this we mean that a data warehouse is a single centralized data source where we can store our data and perform various kind of transformations slash operations on the data. So a data warehouse system, it enables an organization to run powerful analytics on huge volumes of historical data in ways that a standard database cannot. So we can store petabytes and petabytes of data into a data warehouse and also parallelly perform transformations on that data. So this huge level of data operations a standard database does not support. Okay, so we are done with the basic definition of a data warehouse. Now let's try to understand what we just learned through a diagram. So let's suppose if I have data coming from multiple resources, multiple sources. So if you look into the diagram, we have data coming from two sources. One is the sales data and another one is customer data. So let's suppose I have to combine the data, perform some transformation on that data, and then load that data into a data warehouse. So in this case, in these type of scenarios, a data warehouse is the best solution. Like if I want to perform ETL on a data that is coming from multiple sources, so we can do that using a data warehouse, or also means we can store data coming from multiple sources into a single data warehouse. And yeah, we can also perform data transformations or data operations on that stored data. So I have my data coming from two sources, the sales data, the customer data. I have to perform some ETL, that is extract, transform, and load functions on that data. And then once the transformation is done, I will load that data into a data warehouse. So this is the basic analogy behind a data warehouse. So we have data coming from multiple sources. We combine the data, perform our transformations, and then load our data into a data warehouse. But although an important point here to note is that Snowflake, it is built on the functionality of ELT and not ETL. This is an important point to remember. So what happens in the background is we extract the data from multiple sources. We load the data into our Snowflake, that is Cloud Data Warehouse platform, and then we perform the transformations on the data. So the point to note here is that is very important is that Snowflake supports ELT mechanism, that is extract, load, and then transform mechanism. Okay, so now we have gone through the basics of a data warehouse. Now we understand what is a data warehouse. Let's dive a little more deep into what is Snowflake. So Snowflake, it was developed in 2012 and it is a fully managed SaaS service, that is software as a service, that provides a single platform for data warehousing, data lakes, data engineering, data science, data application development, and also features like secure sharing and consumption of real-time or shared data. It is a fully managed SaaS platform, so that is software as a service. This also confuses people many times, like some tend to think that Snowflake is a PaaS platform, PaaS service, but no, Snowflake is a fully managed SaaS service, that is software as a service. And it provides us a single platform for whatever data operations that I have to perform on my data, whatever the requirements be, whether I have to just keep my data into the warehouse or whether I have to perform some analysis functions, I have to perform some data science. I can also leverage the sharing feature of Snowflake. Okay, so also we get to know that Snowflake features out of the box features like separation of storage and compute, on the fly scalable compute, data sharing, data cloning, and third party tool support in order to handle the demanding needs of growing enterprises. So let's break all these functionalities. So we see that Snowflake separates storage and compute. So what we can understand by that is we can separate the storage and compute. The pricing of storage and the pricing of compute are calculated independently. The scaling up or scaling down of storage and compute is also done independently. That is one of the most out of the box feature that Snowflake provides, which is not available in similar other data warehousing technologies. We also get scalable compute. So let's suppose if I have a time period, a time frame where my business requirement will be high. So in that case, I can just scale the compute up to handle the rising requirements. And for the time frame on which my business will be, let's suppose normal or a bit low. So in that case, I can also do that automatically, scale my compute down automatically. I just have to enable that functionality to scale up or down automatically in Snowflake, and then Snowflake's features, it does the rest. We also get the functionality of data sharing in Snowflake. So if there is another Snowflake customer and I need to share a subset of my data to that person, so I can do that. Or there is also another interesting thing here, that if there is someone who does not have any Snowflake account, who is not a Snowflake consumer, so I can share data to that person too by creating reader accounts. And reader accounts are those accounts which are created just for non-Snowflake consumers, entirely for data sharing purposes. We'll see that when we have a tutorial on data sharing feature. We can also do data cloning in Snowflake, so I can create clones of my data samples, and this functionality is also quite important when we are talking about production applications. We can also integrate our Snowflake environment with third-party connectors. So yeah, Snowflake has all these features, all these out-of-the-box features, which makes it quite an interesting technology. And these features for which Snowflake has been in demand for quite some time, and accordingly means I think that Snowflake is a quite interesting technology. It supports quite interesting features like scalable compute, independent compute and storage, data sharing, data cloning, third-party tools integration, and other features. Okay, so now let's talk about a few advantages of Snowflake. But before that, let's have a quick dive in on what were the challenges that were being faced when we were talking about traditional data warehouses. So first of all, a traditional data warehouse, it requires a huge cost to be set up. And even though a traditional data warehouse has been set up, there can be failure rates. Failure chances are always going to be there when we talk about a physical data warehouse. We have an inflexible architecture. So if I have set up a traditional data warehouse, which also requires a huge amount of time, investment, and a good strong knowledge to be set up, even though once we are done with the setup, we cannot play with the architecture. Means once it is set up, then it has to play accordingly. So even if I have to perform any kind of small or minute change in the architecture, so that becomes a quite a challenge when we talk about traditional data warehouses. So moving on to the next challenge, we get high complexity and redundancy. We have slow and degrading performance in a traditional data warehouse. So let's suppose my data is coming on a daily basis in a huge amount. So as the data grows, we will be having slow and degrading performance in my traditional data warehouse, as we do not have independent compute, scalable compute that just scales accordingly as per the demand. And it was also an outdated technology. So these were the challenges that were being faced in a traditional data warehouse. So we have seen the part where we learned the challenges of a traditional data warehouse. Now let's see how Snowflake deals with all these challenges, how Snowflake overpowers all those challenges, and what advantage does this bring to the table. So, Snowflake is built specifically for the cloud, and it is designed to address many of the problems found in older hardware based data warehouses, such as limited scalability, data transformation issues, and delays or failures due to high query volumes. So, we have seen the challenges that a user faces while setting up and running a traditional data warehouse. Now, let's see how Snowflake overpowers those challenges and why Snowflake is replacing the traditional data warehouse architecture. So, let's see that. So, Snowflake is built specifically for the cloud, and it is designed to address many of the problems found in older hardware based data warehouses, such as limited scalability, data transformation issues, and delays or failures due to high query volumes. So, Snowflake is built specifically for the cloud. This means that we do get all the advantages that the cloud technology provides us. We also can overpower the limited scalability feature that was present in a traditional data warehouse, and we can also perform data transformation in a much efficient manner in Snowflake as compared to a traditional data warehouse. So, talking about the first advantages, that is performance and speed. So, the elastic nature of the cloud means if you want to load data faster or run a high volume of queries, you can scale up your virtual warehouse to take advantage of extra compute resources. And accordingly, afterwards, we can scale down the virtual warehouse and pay only for the time we used. So, we have seen that Snowflake is built specifically for the cloud. And let's suppose if I have a time frame where my business will have higher requirements. So in that case, I can scale my virtual warehouse up so that it can meet the high business requirement needs and take advantage of the extra compute resources. And once my business has come down to the normal level, or let's suppose if a time frame is there where my business will be having not so much high requirement, so in that case I can just keep the compute at a scaled down limit, and this also gives us the flexibility to choose for the, and by doing so we pay only for the time that we used. So suppose during the high peak times my virtual warehouse was scaled up to a pretty high size, in that case I will only be paying for the high size for the amount of time that I have used. Once my business requirement has come down to a normal level, so in that case, I will be paying for the normal level compute virtual warehouse size. Talking about the second advantage, Snowflake has the option to store structured and semi-structured data both. So it does have the option to store both formats of data, structured and semi-structured. We can all play with many data formats like CSV, JSON, XML, Parquet, and other data format types. We can combine structured and semi-structured data for analysis and load it into the cloud database, that is Snowflake, without the need for conversion or transformation into a fixed relational schema first. So we just have to pick up the data file and just load the data into Snowflake without having to worry about transforming the data into a particular file format beforehand. And Snowflake, it automatically optimizes how the data is stored and queried. Now let's talk about concurrency and accessibility. So with a traditional data warehouse, when we have a large number of users or use cases, we could experience concurrency issues. So if I have a database that is being operated by, let's suppose, multiple teams are trying to access the data present in a single database. So in that case, I can face the concurrency issue. When too many queries they are computing for resources, a user can face concurrency issues. So how does Snowflake deal with that? Snowflake addresses concurrency issues with its unique multi-cluster architecture. So queries from one virtual warehouse never affect the queries from another. So what we can do is, let's suppose if I have a database and there are two teams that need to work on the data that is present in my database. So in that case, I can create individual warehouses for both the teams. Both the teams will have access to the same data, but the queries from one team that is using my data will not affect the queries for the second team that is also using the same data. So Snowflake does handle this concurrency issue with its unique multi-cluster architecture. And we already know that each virtual warehouse, it can scale up or down as required. And multiple teams, let's suppose of data analysts or data scientists, they can get what they need when they need it and without waiting for other loading and processing tasks to complete. Let's talk about another feature, that is seamless data sharing. So this is also another quite interesting feature of Snowflake. We can share data, we can share our data with Snowflake users, with other users who are registered with Snowflake, and also with users who are not having a Snowflake account, who are not a Snowflake consumer. We can share data with them too through the help of reader accounts that we can create directly from the Snowflake user interface. And this functionality, it allows the provider to create and manage a Snowflake account for a consumer. Now, if I talk about availability and security, so since we know that Snowflake is built entirely on cloud, so Snowflake is distributed across availability zones of the platform on which it runs. So we can create our Snowflake accounts on either of these three public cloud platforms, that is AWS, Azure, or Google Cloud, and is designed to operate continuously and tolerate component and network failures with minimal impact to customers. So whatever availability zones my public cloud platform has, let's suppose if I have created my account on AWS, so whatever availability zones I get with AWS, I can create my Snowflake account in any of those availability zones. So this gives the flexibility to create my Snowflake account in a location that is as close as to my physical location. And if I talk about security, Snowflake is SOC 2 Type 2 certified, and it provides additional levels of security such as support for PHI data for HIPAA customers, and it also supports encryption across all network communications. So these were a few advantages of Snowflake. I hope these points were clear. Now let's move into the additions that we can choose from, the Snowflake additions that we can choose from whenever we are creating a Snowflake account. So there are 4 Snowflake additions named as standard, enterprise, business critical, and the last one being virtual private. So if I talk about standard edition of Snowflake, it is an introductory level. Although we get most of the features in standard edition too, there are a few limitations on this edition. For enterprise edition, we get additional features for the use of large scale enterprise. So if I have to use Snowflake in a large scale enterprise application, in that scenario, an enterprise edition would be the best fit. If I talk about business critical edition, it provides even higher levels of data protection for organizations with higher levels of security. So security perspective, this business critical edition would be a much better option to choose from. And the last one being virtual private. So this edition, it does provide the highest levels of security, and to create account in a virtual private Snowflake edition, we do have to contact the Snowflake team. We do not get the option to choose this virtual private edition when we are creating Snowflake account from the basic user interface. We do have to communicate with the Snowflake internal team to create a virtual private Snowflake edition account. So let's do a point-wise differentiation on all the Snowflake editions. So if you look on the screen, in standard edition, we do get the complete data warehouse solutions. We do get automatic data encryption. Although if we talk about time travel, we get the time travel feature up to 1 day. We get the DR period for up to 7 days beyond time travel, which is the disaster recovery time period. We also get secure data sharing feature in the standard edition. And for Premier support, we also get 24 into 7 Premier support. So these are the options, features that come in handy in the Snowflake Standard Edition. Now let's talk about Enterprise Edition. So in Enterprise Edition, we do get all the standard features. Plus, we also get other functionalities, like we get the option to choose from a multi-cluster warehouse. So if I want to enable a multi-cluster warehouse, I can do that in Enterprise Editions or higher. We do not get that functionality in an standard edition. Also, in an Enterprise Edition, we get time travel for up to 90 days. So we can choose from a time frame for 0 to 90 days. We also get the functionality of materialized views in an Enterprise Edition. We also get the functionality of search optimization service, the SOS feature of Snowflake in Enterprise Edition. And we also get an extra level of column level security in an Enterprise Edition. So don't worry, we'll be covering all these terminologies like materialized views, the search optimization, the multi-cluster warehouse, time travel, disaster recovery. We'll be covering all these topics in the consequent lectures. For now, this is just a basic differentiation on all the Snowflake editions. Now let's jump onto the business critical edition. So in the business critical edition, we do get all the enterprise edition features, and we also get additional security features such as data encryption everywhere. We get an extended support from the Snowflake customer support team. We get the database failure and disaster recovery. And talking about the last edition, which is the virtual private edition, here we get all the business critical features, and also we get virtual servers and a completely different Snowflake environment. So if we are going ahead with the virtual private edition, we will be getting dedicated virtual servers for my environment and a complete different Snowflake environment. And as we discussed, to create an account in virtual private Snowflake edition, we do have to contact the Snowflake customer team. Okay, so we have gone through the Snowflake editions. Now let's talk about the pricing feature that comes with Snowflake. So Snowflake pricing, it is calculated in two ways. One is for compute and the second one is for storage. But the most out of the box feature of Snowflake is that it separates the pricing for compute and storage. So what does that mean? Is that compute and storage pricing, they are decoupled from each other. I'll assume that I have to store 5 gigabytes of data, and I don't need to perform any kind of compute, any kind of transformation on that data for, let's suppose, another 1 month. So in that case, I will be charged only for the storage. And since I'm not performing any compute on that data, I won't be charged even a single penny in terms of compute. I will only be charged for the storage, for the data that I'm storing, and not for the compute. So this is one of the most out of the box features of Snowflake, and this feature is not there in most of the traditional data warehouses or similar technologies. So we can choose one without paying for the other. So if I have to just perform some compute operations on my data, I'll only be charged for the compute part and not for the storage, and similar vice versa. A few features, if we talk about Snowflake pricing, would be is we pay for only what we need. We also get scalable amount of storage at affordable price, affordable cloud price. We do get pricing depending on the region, so we can choose regions based on the requirement. So if I have to choose a Europe region, or if I have to choose a Asia Pacific region, I can choose whatever region that is supported in my public cloud environment, and the pricing is calculated accordingly. And we have already seen that the compute and storage pricing, it is decoupled from each other, so we can use one without paying for the other. So talking specifically about compute pricing, so if I am a Snowflake consumer and if I have to use compute resources, so these are the points that I have to keep in mind. So we are charged for active warehouses per hour. So the number of warehouses that are active per hour, so I'm charged for that. We do not get charged for inactive warehouses. The charge is calculated based on the warehouse size, so we get a variety of virtual warehouse sizes starting from XS, that is extra small, to I think 5XL. So based on my virtual warehouse size, I'm being charged, and also we are billed by second, and a minimum of 1 minute charge is taken into consideration. Now, if I talk about the pricing of storage, so we do get a monthly storage fees, and that fees is calculated based on the average storage used per month. The cost is calculated after compression, and this compression that is performed automatically by Snowflake. So if I'm loading a huge data file into Snowflake, so first that data file will be compressed automatically, and the cost will be calculated based on the compressed data that I am getting. And the storage charge, it is also dependent on which cloud provider we are choosing. So if I'm choosing AWS, I will be charged accordingly for the AWS cloud provider. So how does Snowflake calculate the pricing? So we have to pay in dollars, and these dollars, they get converted into credits, and these credits are then being consumed. So we'll see that when we get into the hands-on, when we look into how to pay the. So let's look into a Snowflake pricing example. So let's suppose if I have created my Snowflake account on AWS cloud, and for region I have chosen Europe, Frankfurt to be specific. So in that case, for an standard Snowflake edition, the charge is $2.7 per credit, and for the enterprise edition we get $4 per credit. For the business critical, we are getting $5.4 per credit, and for virtual private, we do have to contact the Snowflake internal team. So the pricing is calculated accordingly based on the region that we choose to create our Snowflake account on. So let's suppose for AWS cloud, for Europe region, Frankfurt, for each credit I will have to pay an amount of $4. So one credit equals $4, and accordingly we can choose the region. Okay, so let's talk about storage pricing. So we do have two options when we choose the pricing for storage. We can either opt in for the on-demand feature, or we can also go ahead with the capacity feature. So if I choose on-demand storage, so in that case I pay for only what I use. An example, for each terabytes I do get charged an amount of $45. And for capacity, if I talk about capacity feature, get paid only for the defined capacity upfront, and we can see that the total charge that I pay for each terabyte of data when I opt in for the capacity storage is quite low as compared to the on-demand feature, that is $24.50 per terabytes. So how do we differentiate when we go for on-demand storage or when we go for capacity storage? So a recommended path to follow is, whenever we are choosing the type of storage we want, let's just start with on-demand storage. So as per my demand comes in, my storage will be charged accordingly, and once we are sure about how much data I have to store, then we can opt in for capacity storage once we are sure about the storage usage. So that is how you choose for the storage pricing and how you choose between different storage. Okay, so with that, I think we have come to an end of this tutorial. So let's just quickly go through what we learned in this tutorial. So we saw what is Snowflake. We went through the introduction and definition of a data warehouse. Then we saw advantages of Snowflake. We saw what different additions we get when we choose to create a Snowflake account. We also dived into a little theory on the Snowflake pricing. In the next lecture, we will jump into the topic of Snowflake architecture, and consequently we'll be seeing how to create Snowflake accounts and how to do the practical aspect, how to cover the practical aspect of Snowflake. So this was just an introduction video on Snowflake so that you get a little knowledge on Snowflake and be prepared for the consequent videos that I will be uploading in the Snowflake playlist on this channel. So I hope I made my points clear, and make sure to subscribe the channel so that whenever I upload the future videos, you do get the notifications. And yeah, this is an ongoing Snowflake playlist. Future videos, we will be covering Snowflake, and we will be covering Snowflake from beginner to an expert level. We'll also be talking about Snowflake certifications. So yeah, just make sure to subscribe, and if you have any queries, leave those in the comment box. There is also my LinkedIn ID on this channel, so you can connect with me over LinkedIn if you do have any queries, and I will make sure to reply back. Okay, so that was it, everyone. Thank you, and I will see you in the next tutorial.